Welcome to Make Parts Fast Masterclass. Today's video discusses how to 3D print injection molds. Now, one of the things that we were kind of talking about earlier was how 3D printing can become a tool in injection molding. Can you go into that a little bit more?
Correct, yeah. So this is sort of a nascent area that's very exciting. We're getting a lot of interest right now in being able to print tools for injection molding. So the idea here is, of course, you can make hard tools, which are for long production runs. Those are usually made out of steel or some real hard material. There's soft tooling, which is usually made out of aluminum, but is also CNC'd. And that's good for a few thousand parts typically out of a soft tool. And then at the very other end of the spectrum, you have individually printed parts, which is good for, 5, 10, 15, 20 parts typically in terms of economies of scale. It's good for that. What about in between there?
That's like a couple of hundred parts?
A couple of hundred, exactly. So if you need to make a couple of hundred plastic parts that would be injection molded in their production form, what's the right way to get to that? And it turns out that printing the molds to make those parts actually works very well.
Okay.
And we've got a variety of customers that are doing this today. They're printing molds, and they run them just like they do their steel molds with a little bit of design change because plastic is an insulator, metals are not. And so in terms of how the heat dissipates away from the parts, you need to have that factored into your designs. But once you have factored that into your designs, you can print molds. It works really well for small parts, things that are maybe under 4 inches in any one dimension. Real big stuff, you need to be injecting at pressures that the plastic molds can't hold up to. But for smaller things, running at 10 tons of pressure, not a problem at all. Really, any kind of thermoplastic is able to be run.
That was I was going to ask. What are the materials that you would typically use for this?
Same exact, pellet plastic that you're going to run in any injection molding application. Up to about 675 degrees is what we've seen our customers running up to. They haven't needed to go hotter because almost all of the common materials for injection molding are running below that, 675. That's actually a pretty high temp.
Now, is there a specific additive or 3D printing process like extrusion, SLA? What kind of process is
Yes,
that?
so most of our customers are using this system, the ProJet 3500, which is a multi-jet printer. So that's a precision printer similar to SLA. SLA is another good option. You wouldn't use FDM or, as we call it, PJP. Those aren't accurate enough. So you do need a pretty accurate system because as the molds come together, you need real tight, sharp parting lines. Otherwise, you're going to get a lot of flash on your injection molded part. And of course, they need to have smooth surfaces so that the parts will eject properly from the molds and that the parts themselves look good, right? Because if you've got rough surfaces, you're going to have rough surfaces on the parts as well.
So it's more of a plastic material rather than a metal material that you would use for these fixtures and these molds.
Correct, yeah, the molds are being printed in plastic, and plastic molds are good for anywhere from 50 to 200 parts typically is what you'll get out of a plastic mold in terms of life. Now, we also make metal printers, direct metal printers, and we have customers that are making metal molds for long-term production as well out of those metal molds.
Now, you have a part here that you've used that's kind of like a blank for a stamping part.
Yes, yeah. So this is actually a piece of sheet metal that has been hydroformed over a printed die.
And what was the process used for that?
This is also the ProJet 3500 multi-jet printer. And what this goes to show is the impact force that these parts can take. People tend to think that printed parts are very brittle. And in certain ways, they are. It depends on the part, depends on the material that you're running. But for the right application and with the right design elements in the tool or in the part that you're going to make, these parts are very strong. This is standing up to 15, 20 tons of pressure, I think.
I feel like I could throw that on the floor and it wouldn't even break.
Absolutely, you could. Absolutely, you could. Yeah, that's a solid piece.
What's the material?
This is our VisiJet M3 crystal material. So it's a UV photopolymer that's jetted out and then cured via UV process in the ProJet 3500.
And then they just use this aluminum stamping,
Yeah.
hydroforming.
Hydroforming, yep.
Okay.
You know, the pioneers are doing it today, and they're making it work, and we got a number of customers that are doing it, but I think it's a very young space. It's something that's going to take off a lot because, you know, as we move in 3D printing beyond just prototyping, people are looking at making end-use parts directly, and of course that's an area of interest. But then that in-between state about making the tooling that makes the end-use parts is a really significant area for the whole industry. It's an area that has not been exploited yet. As the materials get better, as the printers get better and faster, and as customers start to think through how they can actually take advantage of printed tooling, you know, there's a lot that's going to be happening here in the next few years.
Thank you so much, Tom. I appreciate it.
Thank you, Leslie.